Welcome back. We're going to go ahead and do a couple of practice problems. I'll go ahead and write this one up. It is how many grams of sodium chloride NaCl is sodium chloride are needed to make 200 milliliters of a 2.5 molar solution. It really should say 2.5 sodium chloride solution. Wow, it looks worse than it is. It's actually going to be a lot easier than you think. So the first thing is, let me get those check marks out of the way. We have to identify what do we know and what are we looking for, okay? So the first thing, what do we know? We know it's 200 milliliters. Well, I don't know liters, but because I know milliliters, I can convert milliliters into liters. So I'm gonna go ahead and check it, boom, and say, yeah, I know that. Alrighty, molarity, 2.5 molarity sodium chloride solution. So yeah, check, I know that. So, question is, how many grams of sodium chloride? Okay, so the first thing I like to do right away is identify what am I missing. I want to figure out grams. Well, in this, let me get rid of that. In this formula, I have 2 of 3 variables, so I need to go ahead and figure out moles. I can do that. Let's do that first. Yeah, let's change the order from the last one. It's all good. So let's go ahead and start plugging and chugging. So, molarity, I'm going to put molarity equals, moles per liter. I just shortened it up, okay? 2.5 molarity of sodium chloride solution, boom, equals, we don't know how many moles of solute. I still need to write solute. We don't know how many moles of solute, but we do know how many liters. Well, this is 200 milliliters. So if you're confident to go ahead and just do it like that at this point, that's fine. But I'm still going to teach you how to do it. So 200 milliliters. So all of our conversion factors, there was a list of how many milliliters per liter, how many centimeters per liter. I had given you a list of those before. I'm not sure which thing, but I know they're there. So anyway, 200 milliliters. I need to go ahead and convert that into liters. So there are 1,000 milliliters per 1 liter. Cancel milliliters, cancel milliliters. Okay, so let's go ahead and 200 liters divided by 1,000. Just plain old 1,000, we got rid of our label. Boom, go ahead and divide it. I'm gonna go the long way because it's been a long few hours. It should be like 0.2, something like that. Let's go ahead, 200. I could do the quickie way, but I don't wanna show you the quickie way. My quickie way is just canceling the zeros. That's how I do it, 0.2, yep. I verify the heck out of things. Our label is liters, 0.2 liters. Boom, look at that. So now that you got 0.2 liters, plug it in. So I'm gonna go ahead and plug it in, 0.2 liters. And of course I need to erase this so I can work, okay? Alrighty. So let's go ahead and get moles by itself. Oh, excuse me, I'm gonna change this to blue. 0.2 liters of NaCl solution. All right, so I want to isolate moles by itself to solve for moles. So I need to get rid of this, times it by its inverse, 0.2 liters NaCl solution. Boom, cancel it all, cancel it. Whatever you do to this side of the equal sign, you gotta do to this side of the equal sign. So thereby, 0.2 liters NaCl solution. There we go. Alrighty, so we're trying to solve for those moles of solute. If you watched the last video, you saw me do my little trick, and my little trick is molarity equals moles per liter. I'm gonna get rid of that now. It's the same thing. I'm just making it quick. So molarity equals moles per liter. What do I got here? I got liters, I got big M molarity, and I got moles. I'm trying to solve for moles. But what I'm gonna do is I'm going to, where this big M is moles per liter, take out the big M, put in moles per liter. Okay? And that's liter sodium chloride solution. Alrighty. Now that I have that, because remember this is equivalent to being over 1. Okay? So that's redundant and taking it away. Cancel liters sodium chloride solution. Cancel liters sodium chloride solution. Can't cancel the numbers. You have to cancel the labels. We're chasing labels. Left with moles. Well, that's what I want. I want to be left with moles. So let's go ahead and calculate it. It's 0.2 times 2.5. So times 2.5 equals 1.5. So 0.2 times 2.5 equals 0.5. Making sure I got my zeros right. I don't have anybody here to correct me. Label is moles of NaCl solution equals the moles of, I shouldn't have solution, my bad. Just NaCl. Why? Because the solute of the small little dissolved particles. The solution is the particles in the liquid. You can see that on the previous video. All right, moles of solute. So the number of moles of solute equal 0.5. Okay, did we answer the question? No, we're getting there. So we got this, we have this to figure out that. Now we have that. So we need to figure out how many grams. How many grams is the question, okay? So now we need to figure out the molar mass of sodium chloride. All right, so I'm running out of room. I'm gonna need to erase some things. I'm keeping this. I can get rid of that, I'm not using it anymore. I need a little dry in the throat. All right, molar mass of sodium chloride. It has 1 atom of sodium, 1 atom of chloride. Look at your periodic table. When you look at your periodic table, sodium is number 11 and is 22.99. Well, that rounds up to 23.00. So equals 23.00. I'm gonna go ahead and show some redundancy. There's only 1 atom, so 23.00, okay? There's only 1 atom of chloride. Chloride should be 35.45. It's number 17. Chloride equals 35, or chlorine, 35.45. There's only 1 atom equals, I know I should be using brackets. Yeah, I still have bad habits. 35 point, make that prettier. 35.45. Add them together. 0 and 5 is 5, 0 and 4 is 4, 3 and 5 is 8, 2 and 3 is 5, 58.45, and it has a label, and the label is grams per mole. So, grams per mole sodium chloride. Okay? Now remember, that's a conversion factor. And so that means 58.45 grams sodium chloride per 1 mole sodium chloride. Or you could flip it and do it the other way. 1 mole of sodium chloride is equivalent to 58.45 grams sodium chloride. Okay? It depends on what your needs are. Now, I want to caution you. When you flip it, make sure you're keeping the number together with the label. So many times I've seen students always trying to keep the big number on top and then just put the label on the bottom. Can't do that. The number 58.45 goes with grams. So when you put it on the bottom, it has to go on the bottom with the grams label. They are connected. They're together. So make sure that you know that. So now we have these moles. Let's go ahead and work our problem. 0.5 moles sodium chloride. That answer that we came up for, that. Question is, how many grams? So since you're trying to figure out how many grams, you know your grams needs to be on the top. Okay? But look at that. Grams are on the top. So let's go ahead and do our calculation. We're going to be using this one right here. 58.45 grams sodium chloride, okay, per 1 mole sodium chloride. Cancel moles of sodium chloride. Cancel moles of sodium chloride. So 58.45 times a half. So times 58.45 equals 29.225. 29.225. I'm going to go ahead and put this down here. Looks a little prettier. 29. Just making sure I read it right. 29 point. So with that, we're going to go ahead and just round down. So this rounds up to here. So since this is on the periodic table and this is where our calculation took us, and we are going to the hundredths place, I said round down, my apologies, we're going to round to there. So it's going to be 29.23 grams of salt, sodium chloride. We just answered this question, how many grams? All right, we're going to do one more. Let's see, I had a little practice page looking at how many liters. Let's see if I like that one. Yeah, we could do that. How many liters of 4 molarity solution can we be using? That many grams, lithium bromide. All right, that one's gonna make me think. Let's do it. I like to think. I'm not against it. How many liters of? I think it's gonna make me think, but I don't think it's really gonna make me think. How many liters of 4 molarity solution? 4 molarity solution can be made using, I just pulled up some random practice problems on the internet for it. Can be made using 100 grams of lithium. 100 grams of lithium bromide. So LIBR, lithium bromide. All right, so let's go ahead and erase all this other stuff and get to working. So I'm going to go ahead and do my molar mass first. Say how many liters. So we're looking for, actually I lied. Let's go ahead and evaluate. See what we have, see what we don't have. Okay? We're looking at how many liters. We're searching for that. I don't know. I'm going to put a question mark on it. Let's be kind of focused. That's my question mark. We got 4 molarity. Boom. Check. Got it. Can be made using 100 grams. Oh no. That. I got 2 variables on here. That's going to stink. Alrighty, so let's see. Next thing I'm going to do, I'm going to go ahead and do the molar mass. Because what do I know about molar mass? It involves grams, it involves moles, okay? So it's talking about the actual solute. And the solute in this case is lithium bromide. So let's do the molar mass first. LiBr, lithium bromide. I think I X'd out my chemistry thing. Hang on. Okay. There we go. I found it. I always have it in a different tab. Number one. I'm sorry, not number one. It's number 3 on the table. Lithium. 6.941. So 6.941. And there's only one atom. Yes, this is redundant, but I'm showing it so you always know to times it by how many atoms there are, okay? So 6.941. If you're past that step, that's fine, go past it. Bromide. I don't have bromide committed to memory. So bromide is on number 35, and the mass is 79.904. 79.904, okay? One atom of bromide equals, so then we got 79.904. Okay, so let's go ahead. We really don't need to be that far. We just need to go to the 100th place. So I just rounded according to rounding rules, and it just happened that they both rounded down. So 4 and 0 is 4, 9 and 9, 18, added up, 9 and 1 is 10, plus 6 is 16, added up, 86. So 86.84 grams per mole. Grams per mole. Look at that, now I'm getting lazy. I can write G, I don't have to put out in grams every time, and mole, they take off the E, that's as close as you get. Grams per mole of lithium bromide, okay? So now what do I know? I know 100 grams of lithium bromide. Looking at my formula, I want to know how many liters. I have that. I don't have the moles yet, but I do have the grams. And since I have the grams and I have this, grams per mole, I can use this to figure out how many moles. All right, so then let's go ahead and just write out the conversion factor off to the side. So 86.84 grams lithium bromide is equivalent to 1 mole lithium bromide. Okay, or 1 mole LiBr is equivalent to 86.84 grams LiBr. Okay, so we know, remember, we always start with what we know. We don't just choose one of those because we want a certain one on the top. We always have numbers we're working with. And the number that we're working with here is 100 grams. So we have 100 grams LiBr. It says it right there, okay? We want to change grams to moles. So grams needs to be on the bottom, right? Gotta cancel it. Moles needs to be on the top, because that's what we're looking to get to. So this one is the one that we're gonna be using. Alrighty, so go like this. 1 mole LiBr equals 86.84 grams LiBr. All right, we're looking to chase some labels. We want to cancel some labels. So grams, remember, that's equivalent to 1 over 1. Okay, I show you every time just to kind of help you remember. Once you get going, then you just know. All righty, grams LiBr, grams LiBr. Let's cancel the label. Go ahead and cancel the label with a different color. Cancel and cancel. Now we are left with moles. Look at that. That's what we're trying to solve so far, moles. So 100 times 1 divided by, label. You almost got me. Moles, L-I-B-R. Okay, and then 86.84. 86.84. No label, got canceled. We're left with moles. Finish the math. Equals. So I'm taking 100 times 1 is 100. Divided by 86.84. 86.84 equals, that doesn't feel right. Let's see, 100 divided by 86.84. Okay, that's right. That's right. I got 1.1515. 1515, and then there's a 4. So I'm gonna let it be. So here's the deal. Gotta put the mole, M-O-L-L-I-B-R. Don't be in a hurry to try to round this. Just save it for the end. Okay? It's okay to be 3 places. This, I'd have to look at it. Yeah, I can go ahead and take it to 3 places. It's all good at the 3 places. Okay, but don't, you know what? No, I just told you 2 seconds ago. Don't be in a hurry around it. Why am I going against everything I just said? All right, so what do we have? Moles. Boom, we have moles. We can now put that there. We have this, it's given in the problem. We have moles, we figured it out using the molar mass and the fact that they want to do 100 grams. Now we'll do that to figure out liters. So let's go ahead and erase. I will put this off to the side because I'm going to use it. 1.1515 moles L-I-B-R. Normally I would have paper working down, side paper for scratch. Okay, so let's just go ahead and plug and chug it into that formula. Molarity equals moles of solute per liters of solution. Alrighty, so your molarity right here, 4 molar solution. It's a 4 MLIBR solution. Equals moles of solute, you just figured it out, 1.1515, and that is moles of LIBR. Alright, so over here, liters. Trying to figure out liters of solution. That's the variable to solve for. Solve this, and then you'll be good. So go ahead and do that on your own. Now, the liters is on the bottom, so you got a few things. You can't just be flipping everything, but you can go ahead and cross multiply if you're familiar with that and you're comfortable with that. I'm going to do a long version of what essentially is cross multiplying, and it's the same version that I gave you in the last one. Actually, it's not a longer version. It's all good. Got to get this. Got to get this over there. Okay, and by itself. I probably should cross multiply. You can do it how you want. Times it by liters. Cancel, cancel. Times it by liters. Boom. All right. Is it by itself? No. Okay. Remember, I told you I'm doing long version. Divide it by 4 molarity LIBR solution. Okay. Cancel, cancel. Throw it over here. Divided by, I did it on the bottom. You almost got me. 4 molarity LIBR solution. I have this here to know that I'm out of camera sight. All right, so if you're familiar with cross multiplying, it's fine. Do it how you want. So we're left with liters equals 1.15 moles LIVR. And 1/4 big M molarity LIVR. Alrighty, that's liters. That's liters. This is moles, and this is molarity. Not the same labels. We need to work it out to be the same labels. So, just like over here, molarity equals moles per liter. Okay? Watch this. 1/big M equals liters over moles. Okay, see that? All right, now, so we use this one. We're gonna use that cell there. So we got 1/that, right? See that? 1/molarity. That's equal to liters over moles. Just have to think it out. So that is equal to liters over moles. Whew, that's hard. All right, now cancel moles. Cancel moles. We're left with liters. That's all you're looking for. So do your calculation. Liters LIVR solution equals 1.15. And then, by the way, this is a 1 liter divided by 4. So do your calculation. 1.15 times 1 divided by 4. 1.1515 times 1 divided by 4 equals 0.2878. 0.2875 or 87. I need to call that, man. We're gonna go ahead and call it, round it to the 9. 1.29 liters of LIVR. Solution. So I'm gonna be honest with you, that's the hardest one. And you may have one similar, but not that hard, okay? Like I told you, I just called up some stuff to work the process. So, hey, it's just chasing the labels. Once you learn to chase the labels, you're good. And no matter what, you have to step back, you have to look at the labels and see about chasing them. All right.